It's Actuary Dude over here, looking at a new question. So, a small technology company set up a new venture on the 1st of January 2001. The initial investment cost on that day was £2 million, with a further 1.5 million required on the 1st of August. So that's been 7 full months then. It is expected that on the 1st of January 2002, net income, income less running costs, will begin at a rate of £0.3 million per annum, and the rate will increase by £0.1 million per annum on the 1st of January of each subsequent year. It is assumed that the net income will be received continuously throughout the project. The company expects to sell the business on the 31st of December 2011 for £3 million. So calculate the net present value of the venture on the 1st of January 2001 at a rate of interest of 6% per annum, convertible half yearly. Alright, so I guess in any of these annuity calculations it didn't really say that anything would be half yearly, everything would be in the full year. So we can actually start by just working out the annual effective interest rate, which is what I'd like to do. So that's just going to be, if we use Excel and say that's going to be 0.06 divided by 2, it'll be 1 plus 0.06 divided by 2 to the power of 2, or minus 1, which is the annual effective interest rate. Okay, and so then let's just work out what's going on over here. So over here we've got a minus 2, then somewhere about here, this is August, or 1st of August really, so it would be the end of July. We're saying that it's going to be again minus 1.5, and then from over here onwards it's going to be 0.3, and then it'll go 0.4 because we're going up an extra 0.1, 0.5, and so on. And then over here it will be 3 million over there. And this is all in million actually. So let's work out what that's going to be. So the first bit is minus 2. That's easy. Well, actually, I'll draw this a little differently. I'll just say that the net present value is equal to minus 2 times, not times, plus. So plus, and then we've got a minus there, so in fact the whole thing is minus, but I'll just keep it as plus for now. 1.5 times V to the 7 out of 12 months, and then plus. Now, in order to calculate this, we're using increasing annuities, so the way that it works is it goes our initial amount, 0.3, minus the amount that it increases each time, which is 0.1, that'll be 0.2, times by an annuity. Now this is a continuous annuity, and the amount of years is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 years. So n is equal to 10, like that. And that's just, I guess, a payment of 0.2 going on for each year, and then we're going to use our increasing continuous annuity like that over 10 years as well, and that's times the amount that it's increasing by, which is 0.1, plus we've got our, well actually that whole thing, is discounted then. So this whole bit over there goes back to here, start of 2002. So to bring it back an extra year, we've got to then times it by V, and then we're plussing 3 million V and going back 11 years. So in fact, let's see, I could just write that down. Doesn't quite all fit there on the screen, but that's what it is. So now in order to find this, all we have to do is just use Excel. So really, if you just understand what's going on over here, then we're all good to go. So I'm just going to find a few things. In fact, I'm just going to put that there and say that this is I. We'll find out what D is equal to, which is I divided by 1 plus I. We can find out what delta is equal to, which is ln 1 plus I. And and we'll find out what V is equal to. So V is 1 divided by 1 plus I. And there we have it. So now let's get started. So the first bit is a minus 2. Actually, I'll just put that over here, minus 2. The next bit is equal to minus 1.5 times V to the power of 7 on 12. And now for the positive amounts is we were working out equal to 0.2, that doesn't need to be in brackets actually, 0.2 times, and now our continuous annuity with 10 years. And the continuous one is worked out, times 1 minus v to the n, which is 10, divided by delta. Easy. And then the next bit is that increasing annuity bit, which was 0.1 times everything there. And an increasing annuity, continuous annuity, is going to be an annuity due, so that is 1 minus v to the 10 divided by d, minus nvn, which is 10 times v to the power of 10, and then it's all of that divided by, so I'll just put another bracket there, all of that divided by delta. I can't remember how many brackets I've put in, but that might be it. I'll just put it like that. And there we have it. And lastly, we've now got £3 million, which was going back 11 years. So we have 3 million times v to the power of 11. And in fact, I almost forgot this bit over here, the whole thing. Sorry, this is our continuous annuity. So these two have to be added together. So just to show you, this is, how do I put it? Okay, so this bit over here is 1.5, and then this increasing annuity bit, continuous annuity, is the 3.7. And then when we add them together and multiply them by v, that'll give us the present value. So in fact, I'll just drag that there and say equals. In fact, I should really bring these two over here and just make it over here, add them up. So then, well, I've summed them up and now I've got to multiply it by v, which is this bit over here. And now I can just add up everything that I've got. So the minus 2 at the start, and then that 1.5 that we got 7 months, that we had to pay 7 months later, then all the payments that we're getting over the years, plus the 3 million that we sold. And that gives us 3.1087. So we'll write that down. Equals 3.1087 million pounds. So that's the answer. Thanks a lot for watching.